Welcome class, and thank you for joining me for this notes video. Today we're talking about 7.5, division properties of exponents. This is actually going to be the final rule of exponents that we are going to discuss in this chapter. So to get started, I'm actually going to have us jump straight to this discovery activity. Just like all the other rules, the first thing we're going to do is try to discover for ourselves, mold this rule. And to do that, we're going to do, again, like we've done before, we're going to expand these things out and see what's happening. So we're going to start with x to the fifth divided by x to the third. Well, recall x to the fifth is really just x being multiplied together 5 times. X to the third is x being multiplied by itself 3 times. Another property that you hopefully remember is when you have the same thing top and bottom in a chain of multiplication, you can actually start canceling things off. So I can cancel those 2 x's. I can cancel those 2 x's. I can cancel those 2 x's. Okay? As long as they're the same top and bottom, you can start canceling things off. Well, what am I left with? I see 2 x's left on the top. So I'm going to call that x squared. For our next example, 3 to the 7 divided by 3 to the 2. Well, same thing, I'm going to write this out. 3 to the 7 is multiplying out 3 7 times. And 3 squared is multiplying 3 twice. So, now I'm going to do what I just did before. I'm going to start canceling things off. I'm going to cancel off those 3's. I'm going to cancel off those 3's. And I'm going to count up what I have left. Well, what I'm counting are 5 3's. So I'm going to call this 3 to the 5th. So let's look at what just happened here. So I started with x to the 5th, x to the 3rd, and I got a 2. Started with 7 and 2, and I got a 5. So when we were multiplying these like bases together, we ended up adding the exponents. Well, it kind of makes sense. When we're dividing, we're going to do the exact opposite. We are going to end up subtracting these exponents, okay? So when you're dividing things with a like base, you're going to end up subtracting those exponents. So, dividing powers with the same base, again, you end up subtracting the exponents from each other. Now, looking at the next one, d to the 4 divided by d to the 13. This works even when the number in the denominator is larger, okay? So we have the same base here, so I have d to the 4 minus 13. That's going to give me d to the negative 9. The thing you need to remember when you're dealing with stuff like this, d to the negative 9, remember, you cannot leave it with a negative exponent. So what do you have to do? We have to send it to the denominator where it can have a positive exponent again. And our next one, now we have a chain of things, okay? So looking at this, the first thing I'm going to notice, when I see just an x, I'm going to put an exponent of 1 just to make it a little bit easier for myself, okay? Now I'm going to run through and solve these. So x to the 5 divided by x to the 1. 5 minus 1 gives me an x to the 4. Y to the negative 8 divided by y to the negative 4. Now, this you have to be very careful, okay? You're taking negative 8 and you're subtracting a negative 4. Okay, that's how we're going to find the exponent on the y's. But be really, really careful, please, okay? Remember, subtracting a negative. Remember your double slash method. So really, you're taking here negative 8 plus 4. So y is going to have a negative 4 exponent. So, again, be very careful when you're dealing with all these negatives. Subtracting a negative is the same thing as adding. And now those z's. Z to the 3 divided by z to the 3. Well, 3 minus 3 gives you 0. So you can either consider that z to the 0, or really you have the same thing, top and bottom, and it's going to cancel off. Okay, either way, you could write z to the 0 and end up turning that into 1 in the next step, or realize right away two things with the same power will cancel off. So x to the 4, y to the negative 4. Well, we have something that has a negative exponent here, so we're not quite finished. The x can stay where it is. The x has a positive exponent. The y is the thing with the negative exponent. So I'm going to send that to the denominator so it can have a positive exponent again. And that is going to wrap up that problem for us. Moving right along. Number 1 here is back to one of our basics. Here, again, just subtract those exponents to figure this out. So, for number 1, x to the 4 divided by x to the 5. 4 minus 5 gives you a negative 1. But we can't leave it like that. We don't want to leave it with a negative exponent. So all I have to do is send it to the denominator, where it can have a positive exponent. And again, you don't need to write an exponent of 1. So if you want it as clean as possible, you can just call that 1 over x. It's not wrong if you put that exponent of 1, however. For number 2, forgive me, I'm not quite sure what happened there. So for number 2, the first thing that we're going to do is write in those exponents of 1, okay? Just to make the subtraction easier. So we realize that those are 1s. And now, once I have those 1s there, I'm ready to start subtracting. So for my x's, x to the 1 divided by x to the 3. 1 minus 3 gives me a negative 2. For the y's, y to the 3 divided by y to the 1st. 3 minus 1 gives me a positive 2. Now again, we can't just leave a negative exponent. So what are we going to do? We're going to send the one with the negative exponent to the denominator so it can have a positive exponent. So the x needs to go down to the denominator. The y has a positive exponent, so it can stay in the numerator. And for number 3, same thing. A to the 6 divided by a to the 4. 6 minus 4 gives us an a to the 2. B to the 5 divided by b to the 3. 5 minus 3 also gives us 2. C to the negative 3 divided by c to the negative 8. That's another one of those. We're taking negative 3 and we're subtracting negative 8 from it. When you're subtracting a negative, don't forget, double slash, you end up adding. So negative 3 plus 8 gives you a c to the 5. And when we're looking at that, that actually doesn't have any negative exponents. So really, we're already finished with that example. Looking at our next one, a geometry connection. The area of the rectangle is 72a to the 3, b to the 4. What is the length of the rectangle? All right, so this one I really like. It gets back to geometry. So we know the area of a rectangle. We know that the area of a rectangle is length times width. All right? So if we're looking for the length, because we're given the area and given the width, what do we need to do? Well, dividing by w on both sides, that length is going to be the area divided by the width. That's how we're going to determine that. So area divided by width. So we're going to have the area, which is 72 a to the 3, b to the 4, and we're going to divide it by the width, 6ab. So once we determined that that's the expression that we're considering, now we just start doing the math. So the a and the b on the bottom, again, just to make sure we remember we're dealing with 1 there, I'm going to actually indicate that. So 72 divided by 6, that's going to give me a 12. A to the 3 divided by A to the 1, 3 minus 1 gives me 2. B to the 4 divided by B to the 1, 4 minus 1 leaves me 3. Might you notice, there's no negative exponents here, so we are actually completely done with this example. That is the answer. And looking at the possible choices, that is going to be B as our answer. Looking at our property, raising a quotient to a power. So it probably won't surprise you, just like how when we were doing the product of a power, the power kind of distributed to the terms within. Same thing happens with the quotient, all right? It applies to the numerator and the denominator, both, all right? So to apply this, let's look at a few examples. So 2p over 3, all cubed. So that cube is going to apply to everything inside that parenthesis. So we're going to have 2 cubed, p cubed, and 3 cubed. And again, when we have the power of a number, the simplest version is actually just figure out what that is. So 2 cubed, we know is 8. And 3 cubed, oh, not 81, I apologize. It's going to be 27, right? So that's going to be our most simplified form. Looking at the next practice, this one, notice inside that parenthesis, there's a little simplification we can do right off the bat. So I'm actually going to focus on that first. Okay, so notice we have an x to the 6th on the top of that fraction, and an x to the 1st on the bottom of that fraction. So before I start dealing with that overall power of 2, I'm going to simplify x to the 6th divided by x to the 1. I'm going to call that x to the 5 right off the bat. All right, so I'm just going to clean up the inside of that parenthesis a little bit before we dive into distributing that power of 2. Now that that's gone, now I can start applying that power of 2. So I have my negative out front, and now I'm going to deal with my fraction. So 2 squared gives me 4. X to the 5 squared. Power of a power, I multiply my exponents. Then on the bottom, y to the 4 squared. So y to the 4 to the squared, well again, power of a power, that means we're going to multiply those exponents. And that is going to be our final answer for this one. All right, looking at our next one. So, looking at this, it wants us to consider 2 different ways we can simplify that expression. All right, well, in simplifying that expression, you saw what I just did. I cleaned up the inside a little bit first. So that a to the 7 divided by a to the 5, I right away simplified that to a squared. Okay, I cleaned up the inside of my my parenthesis. So 7 minus 5 gave me 2, and now power of a power would give me a to the 6. Now, you could start by distributing that 3 through first. So power over power, you could get a to the 21st on top, 7 times 3, and then get a to the 15 on the bottom, 5 times 3, and then use that to get a to the 6. So I'm going to cut off my video here. We'll finish the rest together as a class during class. So thank you for joining me, and that is going to be the end of my video.